Hi everyone, in this video I'm going to talk about embedded Linux board, cross-compilation, and how you can set up a development environment in macOS. So if you are an embedded engineer or you are a hobbyist who work with this embedded Linux board, at some point of time you want to develop your own application. And to develop application, we have many options, we have many choices. We have choice of operating system, we have choice of IDEs, we have choice of tool chains. Okay, so there are multiple options uh, to get started with the development work, but I specifically wanted to discuss about how you can set up this in your macOS. Now before we start doing the setup process, I wanted to discuss few more things. Like if you can see, this is a BeagleBone page, and this is a very famous BeagleBone Black board, and it's quite popular embedded Linux board to get started with. You get a lot of examples, uh, support from the community, and this board have a very good ecosystem. uh, if you see the BeagleBone page, you can get a lot of information to get started with. You can download the latest images, you have the documentation, you have design files. The design file are open source because BeagleBone is open source. You can check the design file of BeagleBone and you can make your own customized board out of it. So when you get started, you have a lot of example pre-built to you know to test this board and to play around with this board. But after some time you feel like developing your own solution, developing more application. So in that case, you need to set up a proper development environment. For example, if you are developing an application, a software application, for sure you will need an IDE. So one of the very popular open source IDE is the Eclipse IDE, and it has a very good support for Windows, Mac, and Linux. The other thing you will require apart from the IDE is the cross-compilation toolchain. So what is this cross-compilation toolchain? So I have opened one online editor, and this is an example hello world program written in C. So once I press on run button, so it will compile and generate a binary file. That binary file is understood by the machine, and as you can see, this IDE have run the code also, and we can see hello world printed on the screen on the console. Now this is compilation, which means you are compiling the code for this machine, this Mac itself. Since I am running this in Mac, it is compiling the code for the Mac one. Now if you try to run this binary file, the generated output, in some other machine, let's say if you are running the code which is compiled for macOS in Windows machine, that will not work because these two machines are of different architecture. In macOS, ARM 64 chips are used, and Windows, most of the Windows laptop comes with x86 processor. So these two are different architecture, and for these two, you need to compile differently. The same goes for the embedded Linux board as well. Now, if you are developing your code, let's say you are writing your code in the Eclipse IDE, and you compile the code. So that compilation is native to that machine only. So that will work in Mac OS only. It will not work in the BeagleBone. For that, what you need a tool chain which can generate the binary for this embedded board. What that means is when you compile the code in this Mac OS machine, the code generated will be for the BeagleBone board. That is called cross compilation. Now, few years ago, there was a very good website, Linaro.org, and they were building and maintaining the cross compiler tool chain. So, if you click on this, you will come to this website, and if you go to download, you will see some of the option like you can see here GNU toolchain release from Linaro, which is discontinued now. Okay, so previously Linaro was doing all the development and maintaining the toolchain repository. Now they have discontinued, and ARM itself is developing it. So if you click on this ARM GNU toolchain download, this page will open. Now let's check this GNU Linux first. For Linux, x86 and ARC64 host architecture. For these two architecture, the compiler toolchain are available and available for bare metal and Linux target. Bare metal means like the STM Nucleo board, which have ARM Cortex M series chips. So if you want to do bare metal programming, you can get the cross tool chain for Linux. Okay, that is supported in Linux also. And for the Linux board also, we have the toolchain by ARM. Same for the Windows. For Windows x86 host architecture only means for 64-bit machine in Windows, the toolchain is available. And for programming bare metal and Linux target also, there are toolchain available for Windows. Now, if you come to Mac, there is something very important here. You can see available for silicon host architecture. So Mac OS used to come with Intel chipset also, and now it is coming with ARM based processor and chip M1, M2, M3, M4, M5, right? So for both type of Mac, there are toolchain. Now coming to the third point, available for bare metal target only. As you can see, for Linux and Windows, we have Linux target also, toolchain for Linux target also. But for Mac OS, we don't have Linux target toolchain officially from the ARM. Okay, so you can cross check that here also. If you just scroll down, see this is all the tool chains for Windows. You see ARC32, ARC64 architecture tool chains, and bare metal target tool chains. Now if you scroll down a little more to the Mac OS section, you can see this is a toolchain for bare metal target, which is of 32-bit architecture. Okay, and this one is again for the bare metal target, which is of 64-bit architecture. So we don't have any cross toolchain available for Linux target. Since we don't have any cross toolchain for Linux board, in that case there are two options which you can follow. One will be to download a virtual box and install Linux operating system in it, and then you can do the development. The other option will be to buy a separate window or Linux based machine to work on embedded Linux application development. but these options come with its own price. If you download a virtual box in your macOS, okay, so you can develop application for embedded Linux, but if you want a native application to do the thing, that will be much faster. And if you are not planning to buy another machine to do development for embedded Linux, so you are left with no option at all. Now, to deal with this problem, if you really wanted to do everything on Mac itself and don't want it to compromise on the performance or the experience of developing the application, there is one more option. There is a GitHub page. It is by Messense, and this GitHub page have Cross Toolchain compiled specifically for the macOS. So here you can see there are variety of cross toolchain for different architecture, and the best part is this cross tool compiler will support both the Apple Silicon and the Intel based Mac. Okay, so if you have older Mac which are based on Intel chipset, this toolchain will work on that also. And the new Mac which is coming with Apple Silicon, it is also supported. So to install this toolchain in your Mac, first of all you need to have Brew installed in your Mac. Okay, so Brew is like a package manager, the same we have in Linux apt-get apt install. The, in the same way, uh, we have Brew for Mac. So if you search in Google, you will see this Homebrew package manager. Okay, so click on this and you can see the package manager for everywhere. Homebrew support Mac OS. Okay, so installation process is very simple. You can install Homebrew by running this command, and after installing the brew, you can install the cross toolchain. So to install cross toolchain and to test it properly, I have also written an article on it, and you can come to my website at grid.in and you can go to blog, right? Click on this article, setting up an ARM cross compiler on Mac. So here you will get the full detail and step-by-step process to install the cross compiler. So make sure you have Homebrew installed. If it is not installed, you have to install it from by running this command. Okay, so once you have Homebrew installed, you need to run this command one by one. Okay, and once uh, you have run all these three commands, okay, so this is ARM 7 Linux GNU toolchain. You can install other toolchain also which is available in that GitHub page. I have installed ARM version 7. So once this is installed, you can check the version. See, we have 15.2.0 version. Okay, so this tail we have cross compiler installed in the Mac. Once you install the cross compiler, you can write a simple hello world code. Okay, and to compile that code you need to run this command. So this is the complete toolchain name, and this is the file name main.c .o. After .o you will write the name of the output, okay, executable name. So I am writing it as hello. So this file hello, it is not going to run in your Mac OS because it is cross compiled. Okay, so this will run on ARM board. And if you want to inspect the generated binary, you can use this command. You can run this command in the terminal where your file is located. You just write file and the name of the file. Okay, so you will see output like this. It says ELF 32-bit LSB executable for ARM. So this was a brief discussion on developing application for ARM board, and how to set up your development environment, how to set up the cross compiler tools. So I hope you like this video, and if you want a detailed video on how to set up the toolchain properly, do comment down and I will try to make a video on it.